Have you ever wondered how air traffic control works? Ever questioned how thousands of planes manage to navigate the skies without colliding into each other? Welcome to the intricate world of air traffic control, or ATC as it's commonly known. This invisible network plays a critical role in orchestrating the ballet of aircraft in our skies, ensuring safe and orderly flow of air traffic. ATC is like the conductor of a grand symphony, only instead of musicians and instruments, they manage pilots and airplanes. They're the unsung heroes of aviation, working behind the scenes to keep us safe when we fly. From coordinating takeoffs and landings to ensuring safe distances between ascending and descending aircraft, they have a monumental task. So how do they do it? How does this intricate system work to maintain order in the vast expanse of our skies? Hold on to your seats, because we're about to take off into the fascinating world of air traffic control. By the end of this video, you'll understand how air traffic control keeps our skies safe. At the heart of air traffic control, we find a group of highly trained professionals known as air traffic controllers. Ever wondered who ensures your flight lands safely, or who guides the pilot through the bustling air traffic? It's the air traffic controllers, the invisible guardians of the skies. Air traffic controllers carry a significant responsibility on their shoulders, and it's not a role for the faint-hearted. They are the ones who monitor the movement of aircraft on the ground and in the air. Using radar systems and visual references, they keep a keen eye on every aircraft's position, speed, and altitude. They work diligently, ensuring aircraft maintain safe distances from each other. But it's not just about watching blips on a screen. Air traffic controllers are in constant communication with pilots. They provide information about weather conditions, runway status, and other essential data. They guide pilots during takeoff and landing and even in flight, making sure the aircraft's path is clear and safe. Their role is so crucial that they often work in shifts round the clock to keep the vast network of air traffic flowing smoothly. They work in control towers at airports, in route centers that manage travel corridors, and in approach control facilities that handle the busy airspace around airports. Imagine the level of concentration and precision required for such a job. One mistake, one moment of distraction could lead to disastrous consequences. That's why air traffic controllers undergo rigorous training and are chosen for their ability to make quick, accurate decisions under pressure. And yet, despite their crucial role, air traffic controllers often go unnoticed. They don't wear a uniform or a badge that you can see. They don't get the applause when a flight lands safely, but their contribution is invaluable. Air traffic controllers are the unsung heroes of the skies, keeping us safe on our travels. So how does the process of air traffic control work? It's a complex system broken down into three main parts. Let's start with the first stage, the pre-flight planning. This is where the journey begins. Air traffic controllers, or ATCs, work with pilots to design the safest and most efficient route for each flight. They take into account weather conditions, wind patterns, and other flights in the sky. It's like a massive, intricate puzzle that they need to solve, ensuring each plane has its unique path across the sky. Now, once the flight plan is established, we move to the second stage, in-flight monitoring. This is where the real action happens. With the aid of radar systems and other sophisticated technologies, ATCs keep a vigilant eye on each plane. They ensure that the aircraft stick to their assigned routes and altitudes while maintaining a safe distance from one another. In case of any unexpected changes in weather or mechanical issues, ATCs are there to guide the pilots. They might need to alter the flight path or altitude to avoid any potential hazards. It's a high-pressure job with no room for errors. But the skilled ATCs manage it with grace and precision, ensuring the safety of thousands of passengers in the sky at any given time. Finally, we reach the third stage, landing. This is where the rubber meets the runway, so to speak. ATCs guide the pilots to land safely, navigating them through the busy airspace around airports. They coordinate with the ground control to ensure a smooth transition from the sky to the tarmac. It doesn't stop there, though. Even after landing, ATCs continue to guide the plane, directing it to the appropriate gate for passengers to disembark. It's like choreographing a grand ballet, with planes instead of dancers, each guided precisely and efficiently to their final position. As you can see, air traffic control is a complex process that requires a high level of coordination and communication. It's a symphony in the sky, orchestrated by the ATCs, ensuring that every flight from takeoff to landing is carried out smoothly, safely, and efficiently. Air traffic control isn't just about people though, it's also about the advanced technologies that help make it all possible. Now let's dive into the world of air traffic control technologies. The primary tool used in air traffic control is the radar system. Picture a giant screen with tiny dots moving across. Each dot represents an aircraft, and the radar system tracks their movement. This technology, developed during World War II, works by sending out radio waves. When these waves hit an aircraft, they bounce back, providing the controller with the aircraft's location and altitude. But what about the data? How does a controller know which dot is which plane? That's where flight data processing systems come into play. These systems gather information from each plane's transponder, a device that sends out a unique code. The code corresponds to flight details like the aircraft's identity, its speed, and its destination. Now imagine you're an air traffic controller. You're watching dozens of dots on your screen, each representing a plane full of people. You need to communicate with those planes, guide them, make sure they're safe. How do you do that? The answer lies in communication systems. These systems allow controllers to talk to pilots, giving them instructions and receiving their acknowledgements. These instructions might be about changing course, altitude, or speed, all with the aim of ensuring smooth and safe travel. There's a whole world of other technologies too, like weather monitoring systems that help controllers navigate planes around storms, or collision avoidance systems that warn pilots if they're getting too close to another aircraft. But at the center of it all are the radar systems, flight data processing systems, and communication systems. They're the eyes, ears, and voice of air traffic control, providing the vital links between controllers and aircraft. With these technologies, air traffic controllers can monitor and guide planes with remarkable precision. Like any system, air traffic control faces its own set of challenges. One of the most pressing is coping with the steady increase in air traffic. As the world becomes more connected, the skies are becoming busier. A higher volume of planes not only strains the current infrastructure, but also amplifies the complexity of managing flight paths to avoid collisions. Another challenge is dealing with unpredictable weather disruptions. Storms, high winds, and other adverse conditions can force sudden changes in flight paths and schedules, requiring swift and accurate decision-making from air traffic controllers. But let's not be all doom and gloom. The future of air traffic control holds a lot of promise. Technological advancements are poised to revolutionize how we manage our skies. Artificial intelligence, for instance, is already being explored as a tool to predict flight patterns and optimize routes. This could reduce the workload of air traffic controllers and minimize human error. Automation is another exciting frontier. Automated systems could handle routine monitoring and control tasks, freeing up controllers to focus on more complex and critical decisions. And let's not forget about the potential of satellite-based navigation systems. These could provide more precise and reliable tracking of aircraft, improving safety and efficiency. Despite the challenges, the future of air traffic control looks promising, with new technologies paving the way for safer and more efficient skies. So that's a quick tour of how air traffic control works. We've delved into the crucial roles of air traffic controllers, guiding planes safely through the skies. We've explored the intricate process of coordination and management that ensures smooth operations. We've touched on the cutting-edge technologies that aid in this endeavor, and we've looked ahead at the challenges and future of this complex system. Thank you for joining us on this journey through the skies. If you enjoyed the video, don't forget to like, subscribe, and share. Safe travels.